Hello, folks, and welcome. Our today's speaker, Fedor Usakov, will share his perspective on code quality control for remote teams. So, Fedor, you're most welcome. The floor is yours.
Thank you very much. Just glad to meet such a beautiful audience. Today we will talk about code quality control for remote teams. I would like to share my personal experience. The long way our team has took from the zero control to the state where we are, where I believe we achieved some great results in code quality control. And I would like to apologize that this overview will be really brief because of the timing. And I was trying to absorb as much as possible tooling and aspects of this subject. So it will be really brief, but hope it will still be helpful and give you some great starting points to investigate, to research, to introduce those practices to your projects. Really quick introduction. My name is Fedor Usakov. I'm a senior software developer in Woodway, United States-based company. We are developing a wide range of software from mobile software to enterprise scale CRM systems, and my field of responsibility is web development. I'm working in web development like maybe 20 years, so started from the plain JavaScript till the modern MERN stack. I'm managing as a team lead the international software development team. Our great developers live in Ukraine, Thailand, and United States. So we're true remote team. We never meet each other in person thanks to COVID, but hope one day. So that's actually all about me. And just a quick history recap. So as long as I know, according to Wikipedia, the problem of software quality control is as old as programming itself. So when the first programming language appeared, the first piece of software was written, the problem of controlling its quality appeared. And it's all started really, really simple. Developers just printed out and shared with each other pieces of software code and sharing their opinion. The automation started a bit later when developers start sending each other the patches, the difference in the code base by email, and it was like the first historical moment where real remote development happened by email. I think it's great. So first of all, I think we should define several important characteristics of the good quality software. I think the first and most important thing is clarity and simplicity. The quality software code is really easy to read, easy to understand for anyone who's involved in the project, no matter if it's just a new developer or it's like an old and um, the project manager, the developer who works on the project from the start. The code should be clear to anyone. It includes many aspects like proper naming, proper source code organization, um, a, a lot of different aspects which actually doesn't really matter in the for this presentation. Another important aspect is scalability and maintain and ability to maintain the source code base. The good quality source code is really easy to extend, to expand, to add new features without just throwing in the bucket everything that was done before. So we want to improve and extend our code base, not to rewrite it every single time from the scratch completely. So, and another important aspect is efficiency of the code. It should be, it should work quick, consume as less CPU and memory and other hardware resources as possible. And of course, the quality of the code means that it's should be bug-free and secure. Like I think most of us would agree that in every modern application, like in any like operating system or some complex enterprise CRM system, they all have some internal bugs which is not found yet. So all of the software have bugs, and the idea is to try to minimize the amount of these bugs as much as possible. Like this is a constant and continuous process, and the quality software has as little bugs as possible. Okay, so I see two ways how to like two main approaches to control the quality of the source code. One is manual, which means that it's human driven. It involves like some real person who will take a part of this job. And another approach is automated, like delegate all of the control to the other software or services. I don't know, Androids, chat GPT maybe. And so I propose to start with the manual quality control. It's the first method, the first idea that comes to every single teamlet mind when it goes to software quality control is to start code reviews. It's like I'm just the same. The first idea that comes to my mind was, okay, we need to control our source code. Let's start code review. It's actually a great tool. It's quite effective. It helps to to really precise control each little piece, each commit, each improvement, each feature, each bug fix by reviewing them in the team. But it has some dark sides, according to my experience and many others team leads experience. It can break your team into parts. It can be the source of the conflicts. It can be the disruptive power that will not let you to finish your project, or instead of increasing the code quality, will start slowing the project, will become the cause of the bad software quality, and that's highly possible. Another interesting method which we're actively using is pair programming and so-called mob programming. For example, by this I mean just that two persons from our team just starting coding together at the same time, sharing screen, like looking at each other working process, like talking and chatting, like sharing the thoughts about this process, like asking questions, like that. And mob programming is just the same, but the whole team is involved. So instead of like sharing two screens, we have to share like, I don't know, maybe 5, 7, 10 screens, and everybody like working at the same time, also chatting and sharing the opinion about last series of the Star Wars. Both of these methods are really good for improving like mental health of the team. They're great tool for onboarding new developers, helping them to get familiar with the source code, helping them to resolve like a lot of questions that may have from the start. Also, mob programming is a great way to add some competition to the team. Like, I mean, in the good terms, competition, where developers compete who will like finish this feature better with less code, or maybe even with some additional features. But still, as long as human nature is involved, as long as there is a live communication, even pair and mob development can be a cause of the conflicts inside the team, because I will explain it a bit later on the other slides. So why it is happening, why it is happening like all around the development team in this beautiful shiny world. Okay, so a few words about tooling. So in general, we're not using anything fancy. We just happy with the nice tooling that we have from the GitHub and GitLab. All of these built-in pull and merge requests tooling to review diffs, like to merge them, to like to leave the comment, and so on. It's they're just perfect, and frankly, I think it's the best recommendation possible, just to stick with this built-in tooling for your coder repositories, software of your choice. I know that not only GitHub and GitLab have those tools, many others like Atlassian Crucible is a great tool. For example, I think it's built in for Bitbucket repository users. For pair and mob programming, we are also using only built-in tools. Most of our team is using either Visual Studio Code or WebStorm, and all of them have great plugins for cooperative development and for mob development, and it works pretty well. Like if any problems appear, we just step back and using paid version of the Skype or Zoom or Google Meet, which also works just perfectly fine. For manual quality assurance, sometimes we're inviting like thought companies, someone from outside our company, to do some like research on our projects. We're giving them access and asking them to evaluate, to check if our source code is good, if they're okay with that. Also for security checks, we are hiring like so-called white hat hackers from time to time. It really depends on the project, but for example, if it's like business critical application, we definitely will invite some white hat hackers to test the security, try to hack, to broke things, try to get to the vulnerable data. And like as a result of the job, by making some fixes, we're improving the security and other important aspects of our code. And of course, along with developers, we have a great team of QA engineers whose job is to test our software manually by just clicking through the user scenarios and just monkey clicking and just trying to use this software on the daily basis. Also helps a lot, and this is one of the ways where manual tools works just perfectly fine. Okay, so my core opinion about the code reviews, they really do harm the team health. People get angry with each other. People react really like personal to criticism. It even if the person have a great soft skills, if he like understands that it's code, it's not himself, but still I see many times that people get it personal. If you criticize someone source code, someone's like someone creation, they take it personally. They feel that you criticize them, not just the source code. So and frankly, I think we can't do much about it. There are still tools, there are still ideas that we tried in our team, but in general, we still have to face this truth. This is something that we should like care with us all of the way, or just get rid of the manual code reviews, which is also like a way to go. So how we can improve this? My like first, and I think most of the effective tools, is always start with the telling people something good. So if I'm reviewing someone's code, I always start with the good parts. I'm trying to notice what was done quick, and where I see great creative solutions, like great examples of working code. So I recommend everyone to start with some compliments before you want to criticize someone code. Another advice is a bit strange, because I totally think that only manual code quality control will never work. It will never help you to improve the quality of your code. So the best idea for the manual code audit is to start first with the automated code quality control tools, and only after that proceed with the manual code quality control. Also, during when you leave comments, when you're reviewing someone's code, please be as much tolerant as possible. Do not try like to improve everything. Like in the perfect code review, you should leave comments. You should like suggest any changes only if you see the error. If you see where developer made an error or left some security breach that could be used later for breaking in and steal data or do some harm to the software. I think that's the best way to go, the best way to avoid conflicts. The reviewers who are trying to improve like every single piece of the code, who insist like on some formatting changes, they're not doing a great job in the end. So yeah, actually the fourth point is just about that. So it's better to focus on the real errors and security issues. There are several interesting frameworks from the, how to say, from the expert in human psychology, like the guys who know what's happened in the human heads. We use two of them. One called Clear. It's sorry. It means that before going into any communication, people should agree on several important points, like to be curious, caring, listen to each other, encourage each other, avoid dominating, like, you know, like a senior developer always feels a bit dominant about junior developers. Repeat and revise everything that you said. Petal is a bit more complex framework. It's hard to explain in a few words. I left some links on the dedicated resources, which explains Petal in the details. It showed up as a very effective framework, and it really improves the communication in our team. So even keeping in mind that we all have like a language barrier, have a different way of thinking. We are Christians, Buddhists, I don't know, like macaron monsters, acolytes. I don't know. We believe in different things. We speak different language, but this framework is really helping us to understand each other better. And yeah, I think I'm a bit repeating myself, but I found incredibly useful per development for onboarding. So when the new person comes to the team, it's not just a great person, it's also a great danger to the quality of your code, because without proper onboarding, the new developer can break everything. Just not because he's a bad developer, but because he was not properly instructed. And working side by side, like answering the questions when they appear during the development, showing some like internal tooling during this process is really helpful. It like decreases the onboarding time and decreases the harm that you developer can make to the source code. Okay, so now let's talk about my favorite automated code quality control tools. So the first point and I think it's obvious, are linters and formatters, the tools that check our code for bugs, for code style, um, that formatting our code to fit the code style. With them, is really effective to use pre-commit hooks and continuous integration checks, which is actually mean that before you could commit any changes, your source code should undergo the full check with the linter and formatter, and only after this check is passed, you can send your commit to the removed repository. That's 100% sure that unit tests and even end-to-end tests could improve your could contribute to this source code quality, can improve that, and like can help you to ensure the quality of your code. Another tool is the third-party SaaS solutions that can also absorb your code and give you some important insights, something that you may not know, something that you may missed along the development process. Another tool, which is probably one of the commonly used for web development, is the tooling, the utilities, the services that control the quality of the packages you are using for your software. So in many cases, our software, not just our own source code, it's also some source code that we're importing from the libraries, from the packages, and we have to be sure that these packages is not bringing with them new bugs, new problems, new security vulnerabilities, and there are special tools that can help us with this task. They can control the vulnerabilities and the quality of the packages we are using. And the last tool which we are actively using is so-called code mods. It's the pieces of software that intend to change our code base. Like in your IDE of your choice, you just hitting some button and renaming the variable to some other, changing the name of the variable, and you can do that like across the whole code base. It's a simple case, but you can do much better by writing the special scripts, the special pieces of software. You can do really complex and smart changes across all code base. Like, for example, I don't know if you are familiar with the React framework, which is used for web development widely. For example, you can write the code mode, which will change all component created with the classes to components created as a functions, which is quite complex refactoring, and involves a lot of logic behind it. By using code mods, we can improve our code with the special scripts. Okay, just a few more words about what kind of tooling we're using. Of course, linters and formatters. For web development, we prefer most general solution like ESLint and Prettier. ESLint for linter and Prettier for formatting the source code. Pre-commit hooks and continuous integration. We're using Jenkins and built-in NPM mechanics, which gives us the ability to run some scripts before the commit. Just want to remind once again that all main players on the open source repository field have their own great instruments for continuous integration, and it's quite easy to implement linter and formatting checks on each build with the GitHub or with the GitLab. It's extremely easy. For unit and end-to-end tests, we're using like Jest and Cypress, which I think is pretty cool and working just fine. And also we are practicing like so-called no commit without the test. So every time developer creates a new feature, it always comes with the unit tests. So we can't just send the source code and do not supply it with a several unit tests, which should cover most of the code the user developer created. Also, we are using from time to time third-party code control services like PDS Studio, SonarQube, Clockwork, Codes Veraco. There are many of them. And they works with the wide range of languages, wide range of technologies stack. There are great solutions for Java, C, and C++, Python, PHP, anything. For controlling the quality of the packages we're importing in our project, we are using npm audit built-in feature, but there are also similar instruments from Microsoft for new Get package manager. There is a great tool called pip audit for Python developers, and so on. So just by opening Google, you probably could find some great piece of software for your preferred language, preferred technical stack. And about Codemods, there are like a semi-universal tool from the Facebook, which can work with any text document. So in general, you can do Codemods with the Facebook tooling, but for JavaScript, TypeScript, and I know for the Swift code bases, there are more complex Codemods software where you can analyze the code at the deeper level, where you can have access to the syntax tree and do more complex modifications to the source code. Okay, so how can we improve our automated code quality control? First of all, we have to learn something new like AST, abstract syntax tree. Sorry, it's the tree-like structure that's used by many interpreters and compilers as an intermediate representation of your source code. To understand how AST looks for your language of choice is pretty important, and it's great knowledge for improving yourself as a developer. Of course, I strongly recommend to create your own set of rules for linter and formatter. There are many predefined sets of rules ready to use, but in most cases, it's great to have your own code style expressed as a set of rules for linter and formatter. And this is something dynamic, so those rules should not be carved in the stone. You can remove them, you can add new by communicating inside the team. Sorry. And this is another great point for improvement. So any changes you're making to the rule set should be agreed with the team internally. So it's the democracy fact. So yeah, linter, I already told that. Yeah, linter should be run on every commit and on every CI build. The team lead or someone responsible should control the test coverage and check that it's like above 80%. I think it's a great way to ensure that your code base is properly covered with the tests. So 80% is my how to say, is my perfect set of characters. 80%. And also we can greatly improve using modern AI tools. We found some useful plugins for VS Code and WebStorm that can draft really quickly some basic unit tests, like I don't know, some obvious checks for undefined arguments, for for recursive function, and so on. It's something which we usually writing manually, but these kind of tests are so obvious that artificial intelligence can create for us. Also, we found that modern tooling is quite effective in writing simple documentation for the source code, and we're also using it widely, and recommend to try some of these tools in your team. Okay, so that's mostly it. I hope it will help you to find some inspiration for using one or another tools in your projects to improve your code quality and to start controlling it. And here are some links for the tools we are currently using. And the great book, I actually strongly recommend to try. So there is a not only book, but also a link to the video of the author from the authors of this book. They explain in details. Okay, that's it. If you have any questions, please.
Thank you very much, Fedor, for sharing the insights from your experience. The questions are waiting in the chat, so I would suggest us to stop the recording and move on to the discussion.